Hello and welcome to another one of D's ADD videos. Today we're going to look at enzyme kinetics, a closer look. These are some terms that you should be familiar with if you're going to be discussing the kinetics of an enzyme. So the first we're going to look at is called the turnover number. And the turnover number is literally, as the name implies, how many products does the enzyme turn over, or it's a measure of an enzyme's catalytic activity. So in essence, that's the symbol for a turnover number is kcat, and that's going to be K2. So if you remember the equation, V max equals K2 times the total enzyme concentration. That's known. Then we can solve for K2 or kcat and get Vmax over enzyme total concentration. Okay? So basically represents the kinetic efficiency of the enzyme. How quickly does it turn over? There are some enzymes like catalase, sorry about that, catalase, that literally will convert 40 million products per second. That's pretty impressive. Per second. And then some enzymes won't even complete a whole product per second, so like a lysozyme. Alright, so that's what a turnover number is. Now let's talk about the ratio of kcat to km. In other words, the catalytic efficiency of an enzyme, not the kinetic. This one up here was the kinetic efficiency. Now, we're going to talk about the catalytic efficiency. That's going to be the ratio of kcat over km. Usually under physiological conditions, we are far from the saturating concentrations for our substrate. The concentration so low that we often don't have our active sites occupied with a substrate. So we still can calculate this catalytic efficiency by doing a little bit of math. If you remember the equations, Michaelis-Menten equation. Oh no, we're being invaded by puppies. They broke free. Sorry guys. I'm gonna have to pause. Okay, sorry about that. We have now, yes, okay, we're doing the Michaelis-Menten equations. And if we plug in the equation, in for Vmax right there, we get so when we have the situation in which the substrate concentration is much smaller than the Km, what happens is the substrate concentration in the denominator becomes negligible. And whenever that happens, negligible, we can say that Km plus S is approximately equal to just the Km. That will be the dominant term in the denominator. So what will happen is we will now get this equation right there. So the ratio of K cat to Km gives you an index of the catalytic efficiency. It's basically, that's your new K for the velocity equation. The rate equals K times the products, right? So that's an index for your catalytic efficiency. Okay, so if we were to just look at the ratios, when we restrict ourselves to Kcat being K2 only in this condition, we get this ratio of Kcat for Km, which is your catalytic efficiency. Will equal K1 and K2 over plus K2. But the K1 must always be greater than this. In other words, what we're saying, the reaction can't go any faster than what was K1. You guys remember? K1 is the rate at which the enzyme substrate forms, and that kind of makes sense, right? We can't go any faster than the enzyme substrate forms for the entire reaction, right? So the limiting step is the formation of that enzyme substrate complex. So we cannot exceed the diffusion rate of the combination of enzyme substrate to form the enzyme substrate. Alright, that's pretty much it. Know that we can't really look at enzymes in molar concentrations. What we do is we look at their molar activity. And what we describe is one international unit is the amount that the enzyme catalyzes the formation 1 micromole of product per minute. So what's that amount that catalyzes? Oh, need some more space. The formation of 1 micromole micromole in 1 minute, however much that amount is. All enzymes, we know, are optimal in function at different pHs, temperatures, ionic strengths. So you got to specify what conditions we're talking about here. And some people use the definition of Catal, or the unit of Catal, sorry, and that's the amount that the enzyme catalyzes conversion of 1 mole of substrate to product in 1 second. So I don't know why I'm trying to squeeze that in. I have a lot of space. To product in 1 second. Now the conversion factor for Catals to IUs is 1 Catal. I'll do that in blue. No, I guess we're sticking in red. 1 Catal equals 6 times 10 to the 7th IUs. Alright, so that's a brief rundown on the concepts of turnover number, measures of catalytic activity, basically K2. Turnover number is kinetic activity, basically K2, and then the ratio of Kcat to Kn being the catalytic activity. Alright, so make sure you know how to calculate both and what they stand for. Hope this has clarified things, and make sure you check out the example videos for some calculations dealing with these.